All right, there we go. Think that's a little better. Got things back to normal. All right, here we go. All right, we're back. All right, let's see here. Let's see. Okay, I think that's it. Hopefully it'll be good now. Maybe we'll find out. We'll see. I'm pretty sure it's gonna. I'm pretty sure we're gonna be good on this one. But let me double check. Let's see here. Getting some things. Just getting some things up. You can see. I'm also showing here on the screen my system CPU, so you can see how much CPU it requires to actually deal with the stream uploads. Let's 1 second. Let's see here. Click this button. Clicking over here. There we go. All right. Are we back? I think we're back to it. Let's double check. Back. Let me double check. Okay, cool. Perfect. Okay. Let's see here. Click this button over here. Looking good. Okay. Everything's looking good. All right. All things are good. The system looks maxed out. I mean, you can see, look at the top of the screen. It's like all the cores are at 100%. But this time, we've got the proper network set up, and it looks like we're good to go. Wow, look at that. The subtitles are light speed fast now, too. That's great to see. But the system is definitely maxed out. Good news, new machine on the way, and it's going to be fantastic. It'll be a fantastic new machine. All right, here we go. So today we're talking about Rust machine learning. It's going to be a short stream because we only have, we have like 23 minutes or so. So we have to walk through, we're going to walk through the Rust. It's like a mini Rust framework. It's awesome now. Cool. Shrod, that's excellent. Shrujin, excellent. Good to hear. Yeah, I'm looking at it and it says 100%, looking good, ready to go. Ashrud, well done. All right, cool. Yeah, got to click the buttons, and then sometimes it works better, which is great. I love this. So here on the screen, all right, since we have a short stream this time, and we had some technical difficulties. Hopefully they look all ironed out in this case. So what we can do now is take a peek at some of this code in here. So I did take a little bit a sneak peek at some of these Rust machine learning frameworks, the mini framework that we had Google Jules write for us yesterday, and we did a really good job. Essentially, I loved it. I thought it was fantastic. I did take a quick peek. And yesterday we started looking at the activations file, and it actually looks pretty good. So we have essentially here at the top of the screen, it's going to use indie array2, and array2, I believe, you can let me know if I'm right or wrong. Let me know. I believe array2 here on the screen is basically, it means a two-dimensional array. I think that's what it means. It means a two-dimensional array. And we were also looking at this line right here. The line 2, const e, for me, that says epsilon. That means epsilon for me, but I really want to know. I'm actually kind of curious. I want to search for this. Let's do a quick search. 1 second. Hold on. I just saw something. I got to clear off the screen really quick. I can't show you guys, but I will bring the screen back in a moment. Here we go. Looks good. Okay, screen can come back. Okay. All right, and press this. What is this? Is this epsilon? Const e copy type path. This is e, yep, and std, yep, okay. The constants. 1 second here. It is. Wait, is that epsilon? That is not the epsilon that I know. Hey, thank you for the likes. Appreciate it. Happy to have you here. We got back to it and we figured out the stream settings so that way it's all high quality now. This is a very interesting number. Doesn't that look interesting? Like it's a float number, but that it must just be a different kind of constant. One of these others. But yeah. Anyway, I'm hearing some beeps over here. 1 second, getting some beeps going. Just double checking some things. Okay, looking good. All right, getting back to it. Here we go. Let's jump into it. So. This is our activations. One of the cool things that we saw was that it did do a good job at understanding that even though I didn't ask for it, it automatically added the derivatives. So we asked for activations, and when you're training a model, all you need are the forward pass activations. When you're inferencing the model, you only need the forward pass, which is just the standard functions that are for activations. When you're doing activations, It's a fancy word to say don't. It's sort of like it bounds it. It constrains the floating point number to a certain amount. So as you can see here on the screen, it looks like it constrains it to between 0 and 1, essentially. So that's what it's doing. And it's looping. You can see it loops. So it's doing a map here. Shaji, you are good in coding. Yeah, thank you. Appreciate it. This is great to hear. Yeah, we're doing. That's what we're doing right now. We're doing coding. We're doing reviews. We're reading through some of the Rust code. So this is one of the things that is why Python is so valuable. As you can see here, just kind of letting you know on the screen, there is a lot of symbols, right? We see a lot of symbols on the screen. Rust, we see ampersands, so we see these ampersands here. We also see the angle brackets, right? The ones that are look like alligators. We also have parentheses. Python has parentheses. Then we have this arrow indicator, which Python actually added. They added this in, which indicates what the return value type is going to be for the function. So this is, and then for something like this, for a list iteration, this is actually pretty nice. And Python and Rust are about the same when it comes to anonymous functions or lambdas, right? So you can have a sort of an anonymous function that looks like this. And you can see here that we have one parameter, which is x, which is going to be a floating point number. Hey, I've made use of the cross-stream create for making custom text editor using vibe coding. Did you? So wait, what's it called? Cross-stream create, probably for Rust. So let's Google that really quick. I'm actually kind of curious. Let's do a cross-stream create. Cross-stream create. Here we go. What is this? We could go crates.io. Cross-stream. Here we go. Cross-stream. It's an event stream store for personal local use, specializing event sourcing. Oh, okay. So it sounds like a logging system. A log emission system. Is that what that is? Crossstream XS is an event stream store for personal local first use. Think of it like SQLite. Oh, okay. But specializing in event sourcing. So you can use it to query stuff. Okay. Saji, gamer, you have a question. What do you got? Go ahead. Let us know what your question is. We're going to jump back into the code here really quick. So let's do resize. I'm going to make that a little bit bigger. Let's do something like let's do 50. All right. 1 second. I think that's good. Here, what we'll do is we'll just actually hide that top part. Perfect. Even better. Okay. So here's our forward pass, an activation function for sigmoid, and it also did the derivative, which is a back pass, which is kind of neat. And it requires you to pass in the forward output, which is the original, right? Which is the output from here. And that's what we'll use for what you call it, back propagation. And it has the same for tanh. And would you have it tanh? Oh, automatically. No, it's cross-sturm. Oh, is it? So it's not cross-stream. It's cross-sturm. Did I search for it wrong? It's cross-sturm, or it's a crate, you said? Okay, CROSSTE, cross-term. Oh, like a terminal. Cross-term terminal library for manipulating terminals. Okay, I gotcha. There we go. It makes more sense now. So cross-term is a pure Rust terminal manipulation library that makes it possible to write cross-platform text-based interfaces. It supports Unix and Windows terminals too. Windows 7, not all terminals are tested. Okay, so you probably can make some really cool visuals with this. I'm actually kind of curious to see what it would look like some examples. I want to see some examples. That's what I want to see. I want to see what the example outputs look like. So let's see here. So let's do. It's called cross-sturm, like cross terminal. Cross terminal. Let's do Google for that, and then we'll look at some images. Yes, sir. Okay. I'll be making Jarvis AI, so I have a problem. Okay, that sounds like a good challenge. Roger Rock. Hey, how's it going? Good to see you here. We're currently looking through. This is going to be a Rust stream for the most part, and it's going to be a shorter stream today because we have a hard stop at the top of the hour. We have 15 minutes left, so we might have to do a stream V3, like part 3 essentially of the Rust AI framework. Oh, whoa, this is cool. Look at this. Oh, wow, that is cool. Let me open this up in a new window. Open in new tab. Here we go. Check this out, you guys. Look at what you can build with this framework. Look, you can build these beautiful interfaces. That is really cool. Look at that. Let me zoom in here. You can do some cool stuff with terminal windows, can't you? That's actually really cool. I like the spark line. That's one of my favorites. I like the spark line. That is satisfying because it constantly moves across the screen. It goes boop, 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 and it spark lines. That's really cool. I like that. That's cool. Good recommendation called Cross Term. It's a cross term framework. That's actually kind of cool. All right, so getting back to it here. So we've got our activations, we've got our forward pass and backward pass, and then we have ReLU here. If you've never been familiar with why ReLU is popular, it's because it's more performant. And it's more performant because it doesn't use multiplication. Multiplication in AI is one of the more common standard approaches to merge results. When you're combining, when you're crossing, what do you call it? Essentially matrix multiplication, when you're taking one of the inputs into the previous matrix and then moving it to the next matrix, and you just forward pass through all the matrices. ReLU, instead of multiplying, ReLU is just like an if statement. It's like a greater than 0, and then it'll just return the value. But if it's less than 0, then it sets it to 0. It's kind of a neat approach, and it does a really good job. And then it's the opposite for, it looks like it's the opposite for the backward pass. That's kind of neat, right? Hey, Spectre Shop, how's it going? Good to see you. Hey, the cursed apple. All right, happy to have you here. We have some time left. We're actually good to go. So this is actually kind of cool. This is one of the things that's really great about Rust, I think, is the way that tests are written are always attached. From a unit test perspective, you always kind of want them to be side by side with each of the libraries that you write. But in Rust, it has it embedded at the bottom of every single file for the most part. And this is really cool. I love it. Okay, Shaji, you say it's not run and the problem is not solving. That does sound like a problem. When the problem doesn't solve, you've got a problem, right? I can see that. So you got to, it sounds like you have a challenge. If you're going to build a Jarvis, it depends on what you're going to do. So are you building it with one of the open source models? And the one I recommend in order to build like a full Jarvis, if you're going to really build a full Jarvis, is use GPT OSS and use tool calling, and then merge that with a coding language. Can you read up? Yeah, let me read up here real quick. I might have missed a message. One second. I made use of cross-term crate. Nope, we already read that one. Are you good in coding? Awesome. Yeah. Oh, you know what? It looks like I can't see any further up. You'll have to retype it. What you'll have to do, Saji Gamer, just retype. As a degree with electrical engineering, can I learn all this stuff? I'm truly interested in LLMs. You can. So it is. It's probably one of the more challenging things in my life. So we're actually doing something kind of cool right now, you guys. Check this out. In your life, you'll come across many challenges, things that are difficult to learn, and things that will be frustrating. Things like, for me, what I had challenges with, game engine development, working with graphics engines and frameworks like OpenGL and DirectX, things like artificial intelligence, and things like programming languages that are difficult to learn because the paradigm is shifted, like the programming language Rust. And you know what we're doing right now, you guys? This is kind of cool. We're kind of combining all three of the most challenging things I've ever faced in my entire life. The most difficult things to learn for me have been, game engines and working with those, and like working with the graphics processing unit, GPUs, hardware accelerators, working with Rust and working with the AI. And we're kind of doing that right now. That's kind of what's happening right now. That's kind of what we're doing. Sir, can you explain pointers and references while coding by easy example? Pointers and references, so that's where you're pointing to memory locations, and then you can copy pointers and references. They're both pointers essentially. A reference just means that you have a memory, a memory address that points to data. And then you can pass that around as a pointer. And then you can define pointers, which are memory, usually 64-bit address references. So it's kind of just like pointing to data rather than having copies of data, which is efficiency. It depends on the scenario, but for the most part, it's for efficiency. You want to be able to point to data rather than copying the data. So that's kind of what pointers are. I mean, that's like a very high level, quick example. Hey, Nushad, how's it going? Hey, happy to have you here. Good to see you. Well, Fallon. Okay, what's your thoughts on these AI app building platforms? Okay, so we've got a lot of them, right? You've got Codex, we've got Claude Code, you've got Jules, and these are kind of the sort of more advanced options. And then you've got the higher level ones, which is like Replit and Lovable. These are a little bit more user friendly for non-technical people who are not software engineers. Cursor is a middle ground, right? And Warp is a middle ground. But I recommend, if you're more technical, use the CLIs, use Codex, use Gemini, use Claude Code. Claude Code's my favorite. If you're not technical as much, use Lovable or Replit. These are going to be a little bit easier to get involved with. They're a little bit more simple. Hey, Akash, all you need is interest in getting started. There are a lot of resources on the internet. Yep, Sir and Deep, you're totally right. That's absolutely it. There's so much out there these days. There's so many things happening. Got it, sir. Cool. All right, jumping back to it. We've got 8 minutes, you guys, and then I have to go. This will have to be a short stream today because I've got what you call meetings. I've got a meeting coming up here, and I have to jump into it. So let's see here. So all we did was we got through. I want to get through at least one more file before we end. So we did have some initial latency challenges at the beginning of the stream, which we corrected, and now we are Rust deep learning. Yeah, that's what we're doing. We're doing Rust deep learning. Let's look at the layers by layers. Here we go. So I think this is kind of like one of the. Oh, look at this. Oh, this is kind of cool. Check this out. So at the top of the screen here, it has defined for us. Let me double check to see everything was looking good. Yep, we're looking good here. A trait, which is basically kind of like, you can define methods to be implemented, right? So a layer requires these methods to be implemented in order to be used. Here's something immediately that I see. Wolves, hey, how's it going? Good to see you. What's up? Yeah, we're doing a part 2 from yesterday's stream. We're walking through a small, tiny Rust machine deep learning framework. It's CPU only, but what we're going to do, we'll probably evolve this over time, is to add GPU to it. So that way we can do matrix multiplications on the GPU, because that will accelerate to go a little bit faster. And that will be later. Obviously, we can't do that today. We don't have enough time, but here we go. Check this out. So it needs a forward pass. So this is the number one function here that's going to be used with when you're inferencing, right? When you're using an AI model. The forward pass basically means predict. It means here's your input. I'll give you the input, and then the layer is going to output the results, and that's the forward pass. And in a full model, you'll have multiple layers, and all that data will be passed through each of the layers until it gets to the output layer, which is your final layer, which gives you the answer, and that's usually it could be a binary classification. Thank you for the likes, you guys. Appreciate it. When you click the heart button, I see it on the screen. Like these heart icons, they float up, and it's really fun. I like that. With the forward pass, and then backward pass is only going to be used for training. It's never used during inferencing, but only during training. And it's basically the same as forward, but it's backward, right? Instead of proceeding forward in the thank you for the likes, you guys, yay! Can you tell me? Sure, I can. So here's forward pass in deep machine learning. It's like it goes, right? It goes, on the screen here, it goes this direction, like I can see. So you can see how it goes. But backward pass is basically literally you just reverse it. That's it. You reverse it. Thank you for the likes, you guys. I appreciate it. Here we go. Let's get back to that. And so backwards is just literally backwards. So these are some neat, nice functions that I see here that are kind of interesting. Oh, look at this. Okay. So here's our struct. We've got our inputs and outputs. Okay. So this is important. These are caches, and these are only important during training. You don't necessarily need to save any of these things. So these are just nice to haves. These are nice to haves. You don't need them. The only important thing that you need here are these guys here at the top. And then the activation. So let's rearrange it in this fashion. So these are the necessary. Let's see here. These are required, and these are optional. Optional here. This is for when not training. Thank you for the likes, you guys. And then this is fully optional. Fully optional. Like these are never really required. These are just nice to haves. I bet you anything. This is really weird. I've never written a machine learning framework or a neural network that had D weights and D biases like this. I've never seen it. It's probably a cache for the derivatives, and it's just not necessary. You don't need it, because if you already have the output, right, you're going to have the results that are going to get passed off to the next matrix. So inputs and outputs, right? So those sorts of things. So these you don't really need so much. You need the inputs for backward propagation, things like that. So let's take a look here. I'm actually kind of curious. All right, so we got 3 minutes left, you guys. Oh, I'm so sorry that this was a short stream. I wanted it to be longer, but we had a lot going on today. Just a lot of things were happening, and so we had to keep it short. But we definitely need to get caught back up on this again tomorrow and just resume this part 3, Rust part 3, machine learning. Let's see. We do have 3 minutes left, so we can walk through a little bit more of this. So this is what it looks like when you initialize. So when like ChatGPT, when it got started. Hey, Shyam, hey, good to see you. We're right here at the end. Man, life is so short to master Rust. You're right. Rust is one of the more complicated languages because there's so many symbols and so much abstractions that are possible with it that you can build the world with it. But it is worth it to learn just the basics and the minimal because it is really powerful. It gives you the capability to have the performance of C with compile time concurrency safety, compile time memory safety, which you don't get basically with any other language. You've probably heard things like, Java, and then maybe some other things like that have those types of safeties built in, but they're usually at runtime and you can still run in production issues. But that's where Rust is amazing. It's got compile time safety. It's really powerful. Wolves, hey, hello, Sham, wants to see you again. Yep, good to see you. Serendip, and so many rules to follow. It is, because every time you hit the compiler, it's going to tell you did it wrong. It might give you a recommendation. It says here hey, you did it wrong, but here, try to do it like this. And you're like, okay, fine. And then you take the recommendation, and then sometimes it's like it doesn't do it. It gives you another error. Like it's really crazy. Surgeon, the type safety king. Yes, Rust. Rust is absolutely king when it comes to type safety. It is very strict. Like it is the strictest language you've ever faced. And it's really powerful though, because it forces all of the patterns and the efficiencies to be checkable at compile time, which means that you don't have to worry about it. Once it's in production, it's good to go. If you can still run out of memory, you can still like do heap allocations in Rust and then just right, out of memory error. You can still do that, sure. And you can still create infinite loops, but the Rust compiler is going to still give you, it's still going to solve like more than 70% of the common problems that you run into in production with memory safety and concurrency safety. So you're much better off. I just want to be able to write broken code. I know sometimes you just want to do it. So things like Python and JavaScript, you can do that. You can write as much broken code as you want there. And you can have the application continue forward without crashing, right? So you can do that, which is really cool. All right, you guys, we hit the top of the hour, which means that we have to end, and we are already over. Time is up. We got to get going. Thank you for everyone for hanging out. We didn't get through nearly as much as I wanted to on walking through this Rust framework, but what we can do is we can run it really quick. We're in overtime here. I'm actually late to my meeting now. No, yep, I know. No, yeah, exactly. I use Clippy. On top of that, you do? All right, so Clippy is a linter, and it does extra checks. And it does it, which is it's worth it. We use Clippy as well. Cargo run. Here you go, guys. I just want to run this for you so you can see what it looks like. Just so you can see, it might cause some stream slownesses, or it might not run at all. Oh, there it goes. It's compiling. Is it gonna build? This is why I set up the server, because I thought it was going to give us a better outcome. But I knew the compiling was going to go pretty slow because we need to upgrade our system. See you soon, sir. Yep, that's the plan. So we'll be back tomorrow. And we'll walk through more of this Rust machine learning. And then we'll run more of it. I want to see it run once, and then I'm going to head out to my meeting here. Okay. Okay. Here we go. It's running now. So what it's doing is running through an epoch. Each epoch basically is 100% of the data. So it means that the model has trained on 100% of the data. And you can see here that the loss is reducing. When you see the loss decreasing, that means that it's actually learning, which is great. So you can see that. Means reducing, means that it's learning. And you can see here on the screen that the XOR that we trained it on actually worked. It actually did what we wanted it to do. I hope to catch the live. Yep. Yeah, I'll be back tomorrow. I think tomorrow will be a little bit easier, so we'll have a little bit more time. But yeah, it was great to see everyone. Thank you for hanging out. Just to let you know, it works. What you're seeing on the screen right now is this mini Rust deep learning framework works. It's proving that it works. You can see that this is the XOR operator, and it's exactly the right outputs. And the model learned a non-linear operator called the XOR operator. And so we'll walk through that tomorrow. But it was great to see everyone. Thank you for hanging out, everyone. I'm headed out to my next meeting. We'll catch you guys next time. Oh, wait. If you haven't done so, real quick, join the Discord. I'll only create the link because then we'll be able to see when we go live next. Copy Discord link. We're going to paste that into chat. Here we go. There you guys go. Then you'll be able to see when we go live. The notification goes live there. Also, if you subscribe, then you'll be able to see when we go live next. And we will be next time tomorrow walking through Rust Deep Learning Machine Framework. Deep Learning Machine Learning Framework. Yep. All right. Thank you guys. Have a good one. See you guys next time. Bye-bye. Here we go. Clicking the stop.